Low voltage wires are typically used in low power applications like lighting and electronics. They are not designed to handle the same current levels as standard household wiring, which is often referred to as Romex. Using low voltage wires for applications requiring high currents can create a significant safety hazard. This can lead to overheating and potentially cause a fire. Romex wires are commonly rated for 14 AWG American wire gauge and can safely carry up to 15 amps. Low voltage wires, like those found in Category 5E network cables, are typically 24 AWG and can only handle up to 0.5 amps. This difference in current capacity is substantial. Romex wires have a high voltage insulation rating of 600 volts, making them suitable for household electrical systems operating at 120 volts. Low voltage wires often have lower insulation ratings, such as 300 volts or less. Using low voltage wires in higher voltage applications can damage the wires and create a shock hazard. Romex wires usually have multiple strands of copper conductors. This design provides flexibility and durability. Low voltage wires might have fewer strands or even a single solid conductor. This can make them more fragile and prone to breaking. Given these significant differences in current capacity, voltage rating, insulation, and conductor stranding, it is not advisable to substitute low voltage wires for standard Romex wires in household electrical applications. Using undersized or incorrectly rated wires for electrical systems can create a significant safety hazard and should be strictly avoided. To reiterate the points, consider the following: 1. Wire gauge and current capacity. 2. Insulation and voltage rating. 3. Conductor stranding. Firstly, wire gauge and current capacity are vastly different between Romex and lower voltage wires. Romex, typically 14 AWG, handles up to 15 amps, while low voltage wires, commonly 24 AWG, handle only around 0.5 amps. Secondly, insulation and voltage rating differ significantly. Romex has a 600 volt insulation rating, suitable for 120 volt household systems. Low voltage wires have lower ratings, often 300 volts or less, making them unsafe for higher voltage use. Thirdly, conductor stranding varies, affecting flexibility and durability. Romex uses multiple copper strands for flexibility, while low voltage wires may have fewer strands or a single solid conductor, making them more fragile. Substituting low voltage wires for Romex in household electrical applications presents serious safety risks due to these fundamental differences. It is important to always use the correct type of wire for the intended application to prevent overheating, fire hazards, and electric shock. Always consult a qualified electrician for any electrical work to ensure safety and compliance with electrical codes. To further elaborate on the specific differences, let us consider the specific implications of each factor, starting with current carrying capacity. The current carrying capacity of a wire is directly related to its gauge. The American wire gauge, or AWG, system is a standardized method for denoting wire diameter. A lower AWG number indicates a thicker wire and therefore a higher current carrying capacity. Romex, typically using 14 AWG or 12 AWD wires, is designed to handle the current demands of typical household circuits, which are usually 15 amps or 20 amps respectively. Low voltage wires, often 22 AWG to 26 AWG, are intended for low current signals and power in electronic devices. Attempting to run a 15 amp or 20 amp circuit through a low voltage wire would cause the wire to overheat rapidly. This overheating occurs because the wire's resistance converts electrical energy into heat. If the current exceeds the wire's capacity to dissipate that heat, the insulation can melt, leading to short circuits, fire, and potential electrocution hazards. Moving to insulation, the insulation of a wire is crucial for preventing electrical current from straying from its intended path and causing shocks or short circuits. Romex is typically insulated with a thermoplastic material rated for 600 volts. This level of insulation ensures that the wire can safely handle the voltage present in a standard 120 volt or 240 volt household circuit, even under fault conditions where voltage spikes may occur. Low voltage wires, on the other hand, are often insulated with thinner materials rated for much low voltages, perhaps 300 volts or less. While this may be sufficient for the low voltage applications they are designed for, it is entirely inadequate for household electrical circuits. If a low voltage wire with insufficient insulation is used in a 120 volt circuit, the insulation may break down, creating a path for current to leak to ground. This can result in electric shock if someone comes into contact with a compromised wire or any conductive object connected to it. Moreover, the breakdown of insulation can lead to short circuits, which can damage appliances, trip circuit breakers, and potentially start a fire. Now let's discuss conductor stranding. The conductor of a wire is the metallic part that carries the electrical current, typically copper. Romex wires are usually stranded, meaning they are composed of multiple thin strands of copper bundled together. This stranding provides flexibility, making the wire easier to bend and route through walls and electrical boxes. It also enhances the wire's resistance to fatigue and breakage from repeated bending or vibration. Low voltage wires may be either stranded or solid. Solid core wires are less flexible and more prone to breaking if bent sharply or subjected to repeated movement. If a solid core low voltage wire is used in a situation where it is frequently bent or moved, such as in a portable appliance or extension cord, it is likely to fail over time. This failure can create a break in the circuit, causing the appliance to stop working, or it can lead to a short circuit if the broken ends come into contact with each other. In summary, the differences between Romex and low voltage wires are not just a matter of convenience. They are fundamental differences that impact the safety and reliability of electrical systems. Using the wrong type of wire can have serious consequences, including fire, electric shock, and equipment damage. Always consult with a qualified electrician to ensure that the correct type of wire is used for each application and that all electrical work is performed in accordance with local electrical codes. It's imperative to emphasize that any alterations or installations within a home's electrical system should be undertaken by a certified electrician. These professionals possess the requisite knowledge and experience to ensure all work adheres to the National Electrical Code, or NEC, and local regulations. Non-compliance with these codes can lead to hazardous conditions and invalidate homeowners' insurance policies. Furthermore, proper wire sizing is essential for safety and efficiency. The NEC provides tables, such as Table 310.15b16, that specify the allowable ampacities of insulated conductors based on their size, insulation type, and operating environment. These tables take into account factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable. Using a wire gauge that is too small for the intended current can cause the wire to overheat, leading to insulation breakdown and potentially fire. Conversely, using a wire gauge that is too large is generally safe but can be unnecessarily expensive and make installations more difficult. The insulation type of a wire is also critical. Different insulation materials have different temperature ratings and resistance to moisture, chemicals, and abrasion. Romex typically uses type THHN or THWN insulation, which are suitable for dry and damp locations and have a temperature rating of 90 degrees Celsius. Low voltage wires may use different types of insulation with lower temperature ratings or less resistance to environmental factors. It is important to select an insulation type that is appropriate for the intended application and environment. Proper grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing circuit breakers or fuses to trip and de-energize the circuit. This helps to prevent electric shock and equipment damage. Romex cables typically include a bare or green insulated grounding conductor. This conductor should be properly connected to the grounding system at the service panel and at each outlet or device. Low voltage systems may or may not include grounding conductors depending on the application. If a low voltage system is connected to a grounded source, such as a power supply with a grounding conductor, it is important to ensure that the grounding is properly maintained throughout the system. In addition to wire sizing, insulation type, and grounding, there are other factors to consider when working with electrical systems. These include proper overcurrent protection, such as circuit breakers or fuses, to protect against short circuits and overloads. Proper box fill, to ensure that electrical boxes are not overcrowded with wires and devices, which can lead to overheating. Proper wire connections, using approved connectors and techniques to ensure reliable and safe electrical connections. Compliance with all applicable electrical codes and standards to ensure that the electrical system is installed and maintained in a safe and reliable manner. Ignoring these guidelines can have dire consequences, as evidenced by numerous incidents each year involving electrical fires and injuries. According to the National Fire Protection Association, or NFPA, electrical failures or malfunctions are a leading cause of residential fires in the United States. These fires result in billions of dollars in property damage, as well as numerous injuries and deaths. Many of these incidents could have been prevented by following basic electrical safety practices and using the correct types of wires and components. Therefore, it is crucial to take electrical safety seriously and to educate yourself about the risks involved. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and follow all safety guidelines to protect yourself and your property. To reiterate, the core message, it is not advisable to use low-voltage wires as a replacement for Romex in standard household electrical circuits due to the differences in wire gauge, current carrying capacity, insulation, and conductor stranding. Doing so can create a significant safety hazard, including the risk of fire and electric shock. Always consult with a qualified electrician for any electrical work to ensure that the correct type of wire is used for the intended application and that all work is performed in accordance with local electrical codes. Safety must always be the top priority when dealing with electricity. It is essential to maintain awareness, adhere to guidelines, and consult experts when needed. Electricity is a powerful force, and respecting it is the key to ensuring safety for yourself and others. The dangers of improperly using electrical wiring cannot be overstated. The potential for fire, electric shock, and equipment damage is real and significant. By understanding the differences between Romex and low-voltage wires, following safety precautions, and consulting with qualified electricians, individuals can significantly reduce the risk of electrical hazards in their homes and workplaces. Education and awareness are the most effective tools for preventing electrical accidents.